So hi everyone, and welcome to today's Journeys in QC panel. My name is Richard, and I'm co-hosting this panel with Wyatt. We'll be waiting a few moments for viewers to stream in. To start off, I'd like to invite everyone in the chat to maybe post something fun they did this week. We will wait for one more minute, and then we'll get started right away. Great. I think Wyatt, if you'd like to start off the panel, it's all you.
Awesome. Thank you so much, Richard. Hi, everyone. Welcome to the Journeys in QC Roundtable event. We're super excited to see you all. I'm Wyatt. I'm a sophomore here at Yale who studies physics. And today with us, we have different speakers representing many of our pathways to explore QC. And the cool thing is we have a lot of different backgrounds represented, stories to tell, and we're gonna have them tell you and have the opportunity to interact and send in questions in chat. So I will be in chat reading and fielding your questions, so feel free to ask anything. And we'll take some time to address them after each speaker. And otherwise, Richard?
Yes, thanks, Wyatt. Let me introduce myself. My name is Richard. I'm a senior at Yale studying physics. And without further ado, I'd like to take a few moments to introduce each speaker. So first off, we have Maria Mikhailova, and Maria is a principal software engineer at Microsoft Quantum, focusing on education and developer outreach. Maria is the author and maintainer of the Quantum Katas project, an open source collection of hands-on tutorials and exercises for learning quantum computing using the Microsoft Quantum Development Kit, and the organizer of the Q-Sharp Coding Contest series. She is also a part-time lecturer at Northeastern University, Seattle, and the author of the O'Reilly book, Q-Sharp Pocket Guide. Next up, we have Jake Maliaros. Jake is a senior venture manager and quantum stream lead at the Creative Destruction Lab, or CDL. Prior to joining the CDL, Jake developed quantum and AI software with several organizations, including the Institute of Quantum Computing, IBM, Ryerson, and various startups. In 2015, he co-founded and then led a project to develop a Hyperloop prototype vehicle, which was actually ranked the top 10 in the world in a global competition hosted by SpaceX. He holds a bachelor's in science in physics with a minor in entrepreneurship from the University of Waterloo. And at CDL, he has managed 17 early stage quantum companies in industries varying such as high performance computing, telecommunications, medical imaging, and more. Next, we have Van. Van is a postdoc at the University of Oklahoma, working with single atom arrays. She's a Unitary Fund awardee and a Qiskit advocate. She graduated with a bachelor's and master's of science from the École Normale Supérieure and a doctorate from the Università di Firenze. And we also have Ricky Young here today. Ricky, welcome. Ricky is a software developer and chief operating officer of QBraid. He received a bachelor's of science in engineering physics from Stanford University. So welcome everyone. Thank you so much for joining us here today. So first off, I'd like to begin by summarizing the goals of the panel and what we're hoping to get out of this conversation today. So this roundtable discussion will really be a chance for mentors to discuss the experiencing of pursuing a career in quantum computing in a really rapidly growing industry. And we want to emphasize that, in particular, there are many non-STEM career paths available, even in a STEM-heavy field such as quantum computing. Quantum technologies really will require a myriad of different perspectives, and this event is intended to illustrate the wide set of backgrounds that can indeed lead you to a career in this field. And although this is a roundtable and not aimed to be just a series of presentations, I do like to invite each speaker, even for a few minutes, to just share their stories and journeys into QC and give the viewers a glimpse into exactly how they got there, what were some of the triumphs, setbacks, funny moments, and memorable events that I guess occurred along the way. So, and after each speaker has had the chance to share their stories, we can also direct a few questions after each presentation so that viewers can also have a chance to directly converse with the speakers. So without further ado, I'd like to first invite Maria to share your story. Thank you.
It will absolutely be my pleasure, and I'm going to be fancy and offer you some slides. Yes, I know you said that it's not a presentation, but I have them ready, so why not? Hello again, everybody. Great to see you again. Not the first time this week, but the week is almost over, so almost till the last time. This time I'm going to treat you to some lighter content than usual. I'm going to talk to you about my journey to quantum computing. And it's really a journey to quantum computing rather than in quantum computing, because so far quantum computing has taken a relatively small portion of my journey, but definitely the most exciting one. So looking all the way back, I got the master's degree in effectively applied math from Kiev Polytechnical Institute in Ukraine. It had a surprising amount of physics in it. There was even a mention of quantum physics, but no mention of it being used for computations. So at no point of time it occurred to me during my studies that quantum computing is a possible career option for me. So, of course, I didn't go into quantum computing right away. Instead, I spent around 6 years in banking software industry back in Ukraine, a couple of companies that develop software for banks or were a bank. That's a moderately fun place to be. Just to give you one example of how moderately fun it is, I learned to use version control in a professional environment only after I joined Microsoft, not during those 6 years. Around the same time as the last couple of years in Ukraine, I took the courses at the online Yandex School of Data Analysis, some algorithms and data science topics. That was really interesting, and it probably helped me a little with my next step, passing the interview to join Microsoft and moving to US to do it. But that was still not the beginning of my quantum computing journey. I joined Microsoft in different capacity as a classical software engineer. And I spent a little over 4 years working in a couple of infrastructure teams, basically the underlying layers of various components of Azure and the internal version of Azure. Our motto for that portion was we copy bits for living. And then after that, I started looking for yet another challenge. I wanted something to challenge myself to maybe use some of those topics I learned at university and never got back to. And rather fortunately for me, at that point, Microsoft Quantum team was looking for software engineers to join them and start working on the compiler for what later became our quantum programming language, C#. That was the first time that the team was looking for software engineers without quantum computing background. So I got in, started working on this, well, effectively the first release of Quantum Development Kit. And after we released it, I came up with my current role working on education and outreach, trying to help people learn quantum computing and quantum programming and make it interesting. Basically, I looked at the patterns of the Quantum Development Kit usage and figured out that people are really excited about learning quantum computing. But remember, it was 5 years ago. And so there was not as many accessible educational resources as there are now. So people would be very excited about quantum programming, but wouldn't know what to do with it. And this is how I got into my current role. And then a couple years later, that was actually almost nowadays, 2020, I joined Northeastern University as a part-time lecturer teaching quantum computing. This is more or less the timeline of my journey. And let me highlight 3 rather important for me projects that shaped the last several years pretty massively. The first one was the project that pivoted me into this education kind of work, the Quantum Katas. I think some of you have already tried them out and enjoyed them. And actually one hackathon participant already made an open source contribution to it. I'm super excited. So this is a collection of tutorials and programming exercises that focus on learning quantum computing through solving problems. I did a fair amount of programming competitions back in my day, and then I spent over a decade writing programming problems for programming competitions. So for me, solving problems is a really good motivation for learning topics. And so this project implements this approach to learning. It has really good feedback, so if you're curious, give it a try. The next project was teaching at Northeastern University. This is something that would never occur to me. That's something I would do and I would enjoy. I've always been an introvert, still am, but it's much harder to notice these days. But then in the January of 2020, I got a call from a Microsoft colleague who asked me whether I want to teach a quantum computing course, which starts, well, it actually started yesterday. And of course, I cannot turn down that kind of an invitation. So I said yes. And we had some really nice course materials that we got from a year ago, a year before that, when our team taught a course at the University of Washington. So I took those materials and gave them a refresh. So I had a starting point to start with. I probably wouldn't be able to teach it from scratch. And that's a really interesting course. It comes from software engineering point of view, so it minimizes the math and proofs and focuses on implementing algorithms and solving problems. If you're curious about that, you can read the paper I wrote about it. And the last project is very modern. I've been working on it for the past year. The Pocket Guide on C# programming language. It's coming this summer. It's well, I haven't got as many feedback on it as on the Quantum Katas, but some reviewers said that they learned something from it, and they work with C# every day. So I think it's a good measure of it being a nice book. And it is most certainly a very pretty book. This is all I have for you. Should let other panelists speak as well, and open to any questions.
Great. Thank you so much, Maria, for sharing your story. In particular, I did notice that for a lot of students, the transition from international to getting a position in the US or in another country can be quite difficult. So I was wondering if you had any advice on this area, and like what are some action items that international students can pursue?
That's definitely a challenging thing to do for a lot of people, and I think these days it's even more challenging than it was 9.5 years ago when I did that. I was very lucky because the year I moved to US was the last year you could get an H-1B visa without a lottery. So the only thing you had to do is find a company who's willing to do an H-1B visa for you. You didn't need to also, on top of that, be lucky to actually get the visa in the lottery. Every year since then, there was a lottery, so things became harder. I'm not sure what's the latest good advice on doing that. I know that the thing Microsoft does a lot is hire people in different countries to their office that is not in US, for example, in Canada or in Europe, and then transfers them to a US office. So that's a thing that is easier from the paperwork point of view.
Great, thank you so much, Maria. And before I give the floor to Jake, I'd like to first introduce Shay Allen from IBM. Thank you so much for joining us today. Yeah, and Shay is a IBM Quantum Projects and Events Manager for Workforce Advocacy, and her day-to-day responsibilities are to manage the talent development pipeline and to work towards building a diverse and equitable workforce. She is energetic and outgoing with over 20 years of experience in the IT industry, and she is always known for putting clients first and executing with speed and quality. Since joining IBM in 2000, she has held various positions within different divisions of IBM, and these experiences have resulted in a broad view of the company and its various functional areas. So welcome, Shay.
Thank you.
So next up, Jake, I leave the floor to you.
Thanks, and great to meet everyone, and thanks for hosting, Richard and Wyatt. Maria, great to learn more about you. I'm not going to be sharing slides today, but I'm going to be talking a little bit more just on my journey, some of the hiccups on there, and how sometimes it can be a little bit unconventional how you might be on this journey in quantum. So kind of just starting off, you know, I was always very obsessed with this world of, you know, advanced future technology and science ever since I was young. Led me to want to pursue physics, and I ended up studying this at University of Waterloo. And through my, kind of exposure in high school, actually, there was a teacher there who taught us computer science, but in the light of making games. And at the time, I was very obsessed with this, and it got me very engaged. And the very early part of my career, I was trying to actually make a game we were launching with about 7 people. And at the same time, was very obsessed with, advanced energy, things like fusion technology and stuff like this, and scared my roommates as I tried to build a reactor in our basement, which they weren't very happy about, but found a way to kind of balance it and do it in a way that was quite safe. So got only so far, but as I learned very quickly, and many of you might have already experienced, is the lack of balance between school and all these other projects caught up very quickly. Ended up doing quite poorly in some courses and labs, and had to go back to the drawing board with how I would approach this balance. So that's when I got an opportunity to go to Australia for an opportunity that was actually completely different from my path, but helped me to where I am today. But it's actually for this construction management firm, which was very much multidisciplinary in the projects that are working with engineers, electricians, architects, to deliver these large complexes. And it really gave me a sense of what the work life was like, as well as other skills that I was engaged by on the project management side, and kind of building these multidisciplinary projects. I came back and participated in my first hackathon in Waterloo called Hack the North. Built this kind of virtual reality game and ended up winning. Kind of intrigued me more to like really do these hackathons. I love the concept of it, and ended up doing actually 15 to this day. I was very, very into hackathons. I think it's a great way to test your ideas and push your limits. Around 2015, at this point, a bunch of students and I actually co-founded a team called Waterloop, which was a approach to address Elon Musk's challenge of the Hyperloop challenge, which was a very high-speed form of transport to get from A to B, at Mach speeds. And he was to build the tube, and we were to approach this with a vehicle. So around this time as well is when I first started getting exposed to quantum computing. In around 2016, one of my professors was very deep with this, and I ended up kind of doing quite well in his class and kind of pestering him to assist more. So I ended up getting to do some research with him, and they were working on superconducting quantum computers, the fabrication, as well as the kind of the monitoring of those experiments. My skill set at the time was much more on the software side, so I was helping them build various tools and ways to kind of monitor this through kind of a cloud platform where they before we're kind of doing this very hands-on. Around the same time, I got an opportunity to work with IBM on their cloud team and focused more on machine learning and quantum computing applications. This was all before Qiskit was around, so the Quantum Composer was just coming out, and I got to kind of explore the opportunities of that intersecting with neural nets, and got to present some of that work actually in New York. Around 2017, the Hyperloop competition really, this was when the first one happened. So we got to represent Canada, and we ended up ranking top 15. Overall, we failed a lot of the mechanical tests and to get vehicle in any form of the testing of the tube. So there was still a lot of work to be done, but it was great to kind of have that first step. At this point, we started running out of money. We were losing about 80% of the team to the co-op program, because every 4 months at Waterloo, people would just have these great opportunities to do work. And our leader, unfortunately, was stepping down due to finish school. So I stepped up as team captain at the time, and I decided to take off some time off school. It was a bit of a decision. I even had some of my favorite quantum courses to take there. Called everyone I could, from the business to the technical, really to rebuild the design, the team, and fundraising strategy. And at this point, I got invited to a TEDx Bermuda to do a talk, Idea City in Toronto, many other events to really share this project and rally the troops. We ended up fundraising about 100K in sponsorships, and after kind of further developing the pod, we ended up ranking in the top 10 and getting all those mechanical, electrical tests approved at the competition. We then, at that point, I think it was time for me to kind of move on to further projects, and I also had some time to finish up school. So I ended up passing leadership on. I co-founded a vertical takeoff and landing autonomous aircraft startup, where we worked on that for about 4 months, and that also crash landed, but it was a great opportunity for me to kind of focus more on the engineering side of that. I came back to IBM actually to learn more about software engineering practices around 2018 and further my learnings there. And at this point, I was getting very interested in this intersection of kind of science and business, this kind of commercialization side, and worked with a lot of startups. So did some machine learning with some startups in the real estate industry, as well as worked with biosensor developers working on biomolecule detection for saliva and helping there in their engineering. And then did some advisory work as well. So with some on the neurostimulation side, using ultrasound technology. At this point, and even through all these experiences, I kind of realized like machine learning and quantum technologies were kind of the tools that I was really trying to sharpen to apply as kind of solution opportunities and explore where they could be applied. And this led me to discover CDL, Creative Destruction Lab, actually to come in as a participant in the program, as a bootcamp participant. So this was, at the time I was just learning, but a program for individuals, but also preformed companies to really test out their ideas within the quantum ecosystem, as well as with quantum technologies, to see what was happening in the near term and what was commercially accessible. So at this point, I was developing a solution for something in the machine learning space, and using and leveraging layers of quantum technology. But I also had to finish up school. At this point, all these projects were getting in the way, and I was still pushing back my school and my education. So had to, finally wrap that up. Because of my interest in entrepreneurship, I ended up minoring in entrepreneurship and technology just to kind of finish up my physics degree. And then I got to work with Ryerson for about 8 months as a machine learning research professional, helping kind of the financial ecosystem there. They were dealing with some challenges around how to do these problems where they have thousands of documents that they're going through over 10-year periods for various annual reports for companies. And we were using some natural language processing as well as some other methods to essentially take this unstructured data and actually allow them to do what they did best, which was the analysis, not the aggregation of it. So there were some angles there for probabilistic computing and ways I was looking at leveraging quantum there, and actually took this idea again at CDL as a participant to try to take it a bit more as a mature idea. Through the boot camp, it was very close to forming as a company, but ultimately through the challenges of finding the right co-founders and realizing that maybe it was a bit too early for quantum technologies just through the education of the program and through my testing of the algorithms, decided it was best to kind of take a step back and take a bit of a different angle. So through this, I actually got an opportunity to join the team on CDL, a completely different perspective from what I had normally done, and actually joined the team at the end of that summer as a venture manager. So in this role, what venture managers do is they actually work with the companies that are coming through the program and really help connect and strategize with them the best ways to kind of make use of this mentorship ecosystem that we've developed. And these are mentors from all over the quantum sector, from the scientists to entrepreneurial side, that are really helping these companies prioritize. So it was a completely different angle, but it was a great way that I felt I could give back, but also learn about the patterns of successful quantum ventures. And then since then, I've actually been part of this designing and execution of this quantum bootcamp. As mentioned, have worked with about 17 companies through the program and hundreds of individuals and founders going through. We actually had our own quantum hackathon, which I got to not only manage but participate in, because I just couldn't hold my team back. We had to participate because it's just a great opportunity to refine skills and contribute. But ultimately now I'm the quantum stream lead. And just as a final note, for anyone who is interested to learn more about this program, either from the perspective of as an individual trying to maybe build out an idea or learn more about the quantum ecosystem, or even to join the team at CDL, we're always looking for more. Please feel free to reach out, connect with me on LinkedIn. You can send me a message. I'd be happy to meet and chat more. But thanks for the time today, and great to meet everyone.
Thank you, Jay. That was great. We have one question in the chat about ion trapped qubits in particular, and whether radon could be used or what kind of materials would be viable.
I think, so just a quick thought on ion trap. I think it's definitely a very high fidelity type of architecture. We actually had a company come through called Alpine Quantum Technologies, AQT, that was very much, you know, to the point now where they're developing racks that go into supercomputing centers and such like this. I don't know enough to fully give you a full answer on whether to use radon on these systems, but there's what I would encourage you to do is look into the various ones that different companies have leveraged and different scientific groups have leveraged. They're mainly choosing these atoms because they're looking for high fidelity of the qubits, and they're really just looking to see if they can basically get the types of connectivity that would enable many of the algorithms that we are looking to leverage for application.
Jake, really appreciate you sharing a little bit about your story. I will say that water loop might be one of the most succinct yet smart names I've heard. And yeah, I guess I was just wondering, like, could you walk us through, like, in more detail, like, what was the design process behind that project, and like, did you use any knowledge you learned from your undergrad physics classes or in other projects to I don't know, to create that project?
Yeah, so I mean, the main design objective that we had, which was quite ambitious, was we wanted to have no contact of the vehicle and the rail or the tube at any time. So it's completely levitating in this low pressure environment to reduce friction and drag as much as possible. Because it was SpaceX, they're a rocket company. So what and I'll actually connect this with quantum here, because what it kind of inspired me was they are very much about fault tolerance, right? They want everything to be extremely redundant. If anything fails, the backup kicks in, and that really makes it very complex for the design to be simple when you're doing that. This is what really pulled me into actually quantum error correction, which is an area that I'm very obsessed with in terms of where the field's going. I think it's going to be an very enabling piece because it's all about how you can essentially catch these faults in the system and essentially still navigate your quantum algorithm. In the case of what we were designing and our process there, we used a lot of electromagnetics, thermal design, which came a lot from the curriculum, as well as AI, machine learning, and computing practices, which I had to learn a bit outside of the curriculum to really design kind of a fault tolerant system with the team. We had various teams, different parts of the pod, and we'd have these kind of alignment pieces where we would really make sure that, you know, the mechanical sides were very in tune with the electrical and very in tune with the software. So ultimately, we actually leveraged the eddy current principle from electromagnetism, for anyone who's familiar, we had an aluminum I-beam as what it was moving on, and we actually used magnets to create a drag effect for magnetic brakes, so they would kind of release there, but actually for propulsion and stability as well. So we actually had these wheels, not traditional wheels that move through friction, but on the edges, we put a Hullback array. So this is just an arrangement of neodymium magnets that created a kind of all the field lines outwards in a very dense flux. And this, as they spun at very high velocities, would create a, similar to what you create with friction, a propulsion force for the vehicle. And as they were moving, it would also create a natural stability for lateral control. So we were using this as a way to actually create motion, and for levitation, we're actually using air casters. So these were a thin film of air that is very, very small, but by lifting up on this thin film of air, almost like a hovercraft, we were able to basically, with the touch of a finger, move this very heavy vehicle, right? So the idea was to, reduce this friction as much as possible and make it all work with a very simple state machine in the controls of software based on various triggers the sensors would detect if something went wrong.
I think the example of the Hyperloop is a great example of what you said earlier about how there needs to be this confluence between science and business. And we just had a panel earlier today with Ricky about Duality Accelerator and quantum startups. So I was just wondering if you could explain why exactly it is important for connecting these two things.
Yeah, so and this is also my perspective coming, as you saw, like more from the technical side for very long, and I got very interested and exposed to business, especially last 3 or 4 years. So I would say it's one of those things where even in the CDL room, why we have you know, scientists there like John Martinis, Barry Sanders, Roger Malco, for example, they're coming in there to essentially make sure that the science checks out when these companies are coming through as a business, and the business side is there to check out that this actually makes sense as a market opportunity to create some type of value for someone out there in the world as an economic case. The economics of quantum is something where it's very, very interesting, because that is where truly the intersection of science and business happens. It's a statement where in the solution space of quantum, where what it can do can actually bring some type of economic value, right? So for example, in the light of optimization, where the economics of quantum comes in is something like, you know, solving combinatorial optimization problems more cheaply, right? If you can solve those problems more cheaply, then it enables a whole set of applications of where this could be applied. In the case of, you know, quantum sensors, for example, this is about, you know, reducing and improving the efficiency and allowing for more distinguishability within signals within the data of quantum sensors. So really making those a bit more accessible and affordable. You know, in the sample, for example, in healthcare, you know, making MRI a bit cheaper by bringing these sensors into play, for example. There's various I could go into, but really I would say that as a conclusion is how we're going to actually get this outside the lab and eventually get this in a setting where people are going to be using it every day, something where we're seeing kind of AI already start to integrate into our everyday lives and our products seamlessly. We don't even realize it, but it's kind of in the backbone of a lot of the prediction problems that our systems are dealing with. So I think it's slowly going to be emerging in as we get these NIST technologies more understood and applied. But of course, as we know, this fault tolerant regime is where the true floodgates are going to open for the applications of quantum. And really, we're hitting the tip of the iceberg today. So very exciting.
These are all really amazing points. Yeah, I really appreciate taking the time, because I never really thought about exactly why like you needed the two at the same time. But thank you so much. Yeah, next up, Vaughn, if you would like, I'd like to give a few moments for you to give us a glimpse into your journey.
Sure. So I took a pretty traditional path. I did my bachelor and master in physics in France, in the École Normale Supérieure. And back then I have a lot of experience working with optics and working with like photonics group in France. And like since then until now, I did mostly experimental physics, and most of the experimental quantum setup that I work with can have application in quantum computing. So quantum computing was always one of the options when we test out our quantum experiment, but we are not specifically focused only on quantum computing. We're also working on quantum simulation, metrology, sensor, and other application of our quantum system. So while I was in France, I was working with Nicolas Treves and Claude Fabre, and we were working with building a cluster state using multi-mode laser, and it was a very exciting project where, like, normally outside of my normal physics knowledge, I also learned other electronics and calculation that I need to use to build like fast homodiection circuit that I was working with them. And it was very exciting for me. And then I decided to move to Italy, and I was doing my PhD in Firenze. And in there, I was working with another quantum system, which is a Bose-Einstein condensate. And I did 2 different projects. One was more on the condensate matters theory side, and then I was working more on exploring different geometrical phase of the system and how does it affect when it's under like quantum xenodynamics. And then after that, I have another project also with the Bose-Einstein condensate working on sensor. And in that project, I did a lot of, I also learned lots of new things. I learned a lot about signal processing since I had to build a sensor. And I also really like it. And then the main point where I start moving toward quantum computing is between my PhD and my current position here in the US. I did in Seoul National University in Korea. And I was actually doing that visiting researcher term in the computer science department. And I never learned computer science in my life. I was a physics student. But after I graduated from my PhD, I did that project in the computer science, and I got to see how a group, a community grow together. Like usually if you are in a quantum physics lab, there's always student, people like graduate student, postdoc, professor, they are all coming from physics and they are all sharing the same point of view. But actually in that lab in the National University, they have people coming from material department, engineer, technicians, people coming from computer science, mathematics. And that made me realize that like with a group of with people with diverse background, you have different point of view, but also everyone have different strong point knowledges. And that's why you lead to a very like that group is the fastest growing group that I seen. So they were having a single ion trap system for quantum computing. And when the professors just start there until they have the full setup done, it's only take 9 months, because the student in material department, they build the chips for the ion trap is themselves, people in physics making the vacuum chamber, and people in computer science do the coding. And like that made me realize that in the quantum computing industry, that's where lots of people with different background, people with computer science background, people with physics background, they're all together, and they like, it's a very fast growing industry. And that's when I start feeling like I want to acquire more skills outside of the physics world, outside of the experimental physics world. And also I want to meet more people, and I get more and more and more invested in the quantum computing industry. And then I start my postdoc in America, still in experimental physics. We are working on having a single atom cesium array in our lab, and we already demonstrate this array, and we are now working on getting them entangled, and then trying different scheme with this setup that we are currently having. And that was also a very interesting experience where I start building the whole system from scratch. But this time I got much more knowledge because I learned computer science now, also learning like electronics and having much more skill. And I feel that I was able to build, like also when I start the postdoc term in America, the lab was empty, there's nothing, there's only the optical table. And I feel like when I start having more skill in computer science or electronics, I was able to build the experiment in also a faster pace, but also having much more understanding of my setup, much more choice to choose the correct items for my setup so that it works well. So I was very happy that I got into the quantum computing community and get to meet more people. I signed up to become an IBM advocate, and that's where I met a lot of different people from different backgrounds, very interesting like community. And then I got suggested by different QSkit advocate to apply for a fund called the Unitary Fund, which I'm representing today. So I want to talk a bit about that project, because most of my project was working on hardware, quantum hardware, like photonic system, co-atom system like Bose-Einstein condensate, or single atom array, or ion trap. But this project I did with Unitary Fund, I was only doing it theoretically, and Unitary Fund actually gave me a very good chance to be in a community, to meet a lot of people. They have a Discord, and then at first I couldn't think, I didn't think that I could make it possible, but I got to discuss it with many people in the Unitary Fund community, such as Nathan or Dan or Andrea. They all helped me a lot, and that's how I got to actually work on a more theoretical quantum physics project. So I wanted to talk a bit about that project with you, share about that project with you today, so that if you're interested, maybe you can also like work on it together, or you can send me an email. It's an ongoing project that I'm working. I don't know if you see my slide.
Yes, we see it. Thank you.
Yeah, so like usually when we work in quantum computer, we work with qubit, which is two-level system with 0 and 1, right? But lots of system in my experiment, like photons, atoms, they have much more level than that. And if you use a qubit, which is a quantum unit that have high dimensional system, you can also carry more information, but also the entanglement structure is richer. It's super useful for quantum key distribution. So that's linked me to this project where I want to build a circuit simulator for high dimensional system. So we place ourselves in the Heisenberg picture. So we only do the circuit simulator, not taking care about the input state or output state. For this, I try to make a universal universal basis for a high-dimensional system. So you probably already know in the quantum computer, the normal universal gate set for quantum computer. You have the Pauli matrices XYZ identity for two-dimensional, and then you have all the Clifford, which is the one that conserve the Pauli matrices, like the Hadamard gate or the S gate. And then you have another one that is not conserving the Pauli matrices, but allow you to, like, since it's not conserving the Pauli matrices, it's allow you to reach all the point of your block sphere, and to reach to approach any quantum state within a small area, which is the T gate, that have the dual rotation that is an irrational multiple pi. That's allowed you to dance your whole block sphere. And I want to do similar things with D dimension. We already got all the mathematical layout for this. And then, I was talking for single qubit or single qubit. Of course, for multipartite system, you also need another control gate. So I have a generalized Pauli group, generalized Clifford group that I have been written. I will not go to the detail, but I have been laying out the mathematical layout for this Pauli group and this Clifford group. And I also found another non-universal gate to make this universal, and having this Pauli group and Clifford group all defined in my Python. And then on the process of making a package that I can put it on an open source for everyone to use. And that's the project that Unitary Fund have awarded me. And I'm very happy about his project, because this is my first time to do something that is not experimental physics. and to meet a lot of people in the community, such as people in Unitary Fund that like help me with it. So that's basically the idea of it. And that's all I had to share today.
Thanks for sharing.
Yeah, also I
yes,
want to talk about the question you were asking to Maria about coming to the US as a foreigner. So she said it was very difficult to get a lottery from the H-1B system, which is completely true. I think it's not as difficult if you go to the academic road, which is another option. Of course, people might have their own preference between academic and industry, but I believe if you work for a nonprofit organization, your H1 does not have to go through a lottery system. It will not be H1B, it's going to be H1, I remember, but like you don't have to go through a lottery system. You work for a nonprofit organization, which is the university. Also, at the earliest, so that is when you apply for associate professor, right? On the earlier career stage, such as a postdoc, as I am, you have an option to use a J1 visa as well. So yeah, that's what, yeah, just to answer that question you asked it before.
Yeah, I think these tips are definitely been very useful for anyone watching. So thank you. Yeah, and also I appreciate you telling us a little bit more about Unitary Fund. I actually, a few months ago, I actually also stumbled upon the Discord link for the Unitary Fund. I also joined it, and yeah, like you're completely right. The community is extremely vibrant on the Discord, and I also had a chance to use one of Unitary Fund's packages before with regard to exactly with MITIC, and I think it was a really nice way to learn about some basic error mitigation strategies, and like Jake said, it allowed me to I guess learn how important it really is for making your algorithms more robust, and especially in this NISQ era. So yeah, thank you so much.
Yeah, so just to add, Unitary Fund is giving our micro grant for anyone. So you can just go to their website and just submit your proposal, your project, and they're giving out micro grant, and that's how you become part of the community. Also, they're having the MITIC package that you also can also use and join the community of Unitary Fund. And yeah, I think it's very good. And they are I think the main sponsor IBM, but they also have like sponsor from other companies such as Microsoft, Alphabet X, which is like formerly Google X, and other company. And so they are giving out lots of grants. I'm just saying, if you are a student and you are not yet having a job, you want to have some small allowance and you want to start some small project, then Unitary Fund is definitely the way, the place to go. You can just go there and submit your proposal and work on your project independently. It does not have to be a job, right? But you still get your funding and allow you to do some project.
Yeah, thanks for sharing those resources, Don. And I'd encourage everyone to check that out. Check out the Unitary Fund website, and yeah. So next up we have Ricky. If you may, please.
Hey, Richard. And yeah, thank you guys so much for having us. It's always great to be, part of Cuberate, as well as just supporting these hackathons. They're super important and keeps the quantum computing community going. And just to kind of start off, I guess for myself, I very much have kind of like grown under the footsteps of every person that is on this panel, being the youngest most likely here. Quite literally, last year I was part of the CDL bootcamp, which Jake was running with a fantastic team from CDL. I highly recommend to just apply and just try your shot at getting in, because the opportunities that I didn't realize maybe during my academic career were just the sheer amount of like industry involvement that is just like there to support and are very eager to support, that just was available through CDL. And I think that includes people from Microsoft as well as IBM and Xanadu and all these amazing companies. So just thinking about myself, I think I've come from a very incredibly privileged and lucky background. This is where I think, when it comes to immigration and stuff, when it comes to just my position and being able to do cool things in quantum computing, it's very much because I grew up in the US. I think there's a lot of opportunities here, and I did have the privilege of getting into Stanford, which is, again, a very lucky thing, and I also had essentially a lot of opportunities that were given to me that were perhaps something that not only through hard work, but also a large amount of just luck that I just like stumbled upon, to be honest. And I think one of the most important things in my life, and as well as just in my short time in QC after studying a lot of it in my undergrad at Stanford, where I focused a lot in terms of just a good amount of machine learning. I think you just kind of end up doing a lot of CS at Stanford and kind of focusing into pouring yourself into a lot of the engineering side of the engineering physics program as well. I think kind of enjoyed the very fact that, there's an intersection where linear algebra just kind of like sprawls, kind of like unkempt through QC as well as ML. And I really enjoyed that. And I think there was something that kind of intrigued me there and wanted me to like kind of get into it a little bit more. But I think what really pushed me to do QC was I actually had a benign lung tumor right around when COVID just started. And I think that was when I realized you really only have one life. You only have one shot at doing cool things and doing like something. And it sounds so cliche, like truth be told, I've like watched, one or two times of, Steve Jobs saying, oh yeah, this world is for you to take or whatever. But I think it really struck me that if you want to do something cool, like you shouldn't like waste yourself to kind of just find a job. And I realized that like if I really had an opportunity to do something in quantum computing and just kind of start to apply to a lot of these startups. And I think that's where I really enjoyed the intersection of being able to make things accessible through various channels, which QBraid does. Not only do we do that through a software stack where you'll be able to transpile from various languages, such as, Qiskit to Amazon Braket, but also I think we also offer kind of a community platform. So not only are we like on the social side, but also on the stack as well. I think that was very attractive to me because as much as Jake was talking about getting started in quantum in 2016, 2017, there was a lot that I just simply didn't know was available. And it's only like after a while that I realized, and after, Stanford's Quantum Computing Association was set up, I think 2 years ago and whatnot, that it's like a lot of doors have opened and a lot of these like very vibrant communities like Unitary Fund, like QOSF are like keeping everything going. And I would just really want to be part of that and part of that in a large way. And I think if you only have one shot, you might as well just kind of pour yourself into it. And that's kind of what I have been doing for the past year at QBraid. I started off as an intern, and then given that we are a super small team, like have kind of assumed the role of COO, but to be honest, it's just 3 people. So there is nothing to operate. It's just coding all the time and then talking to amazing people, whether that's investors or business people or physicists, and just kind of discussing essentially like the future of quantum computing, as well as like the current status of it, which is turbulent and so cool to be part of. And essentially through, I think, this opportunity at QBraid, I think is again like a very privileged thing that if I didn't maybe have like lung surgery, and if I didn't like have this moment of like realizing that, I should kind of pour myself into one thing and just go for it. Plus, if I didn't, end up realizing that QGrade was sponsoring QC Hack, I may have never done all of this. So it's like super, I think, circumstantial and contextual. And I think the one thing I want to realize here is that like it's your quantum journey, I think, can happen from anywhere, and it's very spontaneous. And of course, you can do a very traditional path as well, where you take a PhD, but like don't, I guess, like be discouraged if like you think that you must get a PhD, because there are amazing people who are doing so much amazing work, like Michal Senhui, as well at, I think, Zapata, and all these people who essentially are kind of leading the charge even without like a PhD. And then that's simply because there's just so much work that needs to be done, and so many amazing people that can fill in those kind of spots as well. So that's a little bit about me. It's not much, and would love to kind of hear more from everybody else, to be honest, and kind of get inspired.
Oh, thank you so much, Ricky. I think it's always very humbling and very inspiring to hear, especially when you've been through some very major personal challenges, and to find that like moment of clarity in what you want to do. I guess to follow up on that is a less interesting question, but it's one that I think a lot of viewers will relate to, and it's I know usually people go into QC with this specific area that they're focused on, whether it's from the more physical side with physics or chemistry, or from the more computer science perspective. But it seems like you, since you did the engineering physics program at Stanford, you sort of had this really foundational, solid physics training, but also got all the CS training like through the project and through the degree. Whereas I think a lot of students will have specific training on only one of these areas. Like, for example, Vaughn said earlier that she only encountered CS like really later on in her academic career. So I was wondering if you have any advice as to how a student should approach about learning a little bit from each of these areas. Yeah.
Yeah, I think, again, I'm going to have to check my privilege there. CS is kind of easy when you are surrounded by 70% of people taking CS classes, or maybe even more. It's like osmosis at that point. And, there isn't a night where you're coming back from class or something that like there isn't like a squadron of people working on some CS project, and just listening in is very easy. I think I tend to put myself as a generalist more, where I try to fill in the spots of intersection. But if you want to get into CS, there's so many great courses as well that are available. And I think getting involved into the open source community is probably the best way to just get started, pick an issue, and then just kind of go through the motions of making sure that your code is clean, making sure that like you meet the expectations and like understand how kind of the industry expectations are probably pretty valuable and a pretty easy way to get started if you want to get into QC, and plus you don't have like quite the strong background in like CS. Yeah, there's so many tutorials too. So
Yeah, thank you so much, Ricky. Yeah, like along the theme of like accessibility, I think QC is definitely aiming to become a really an open source accessible field where people are trying to seek support and help from each other directly, rather than through like a expert or a person with more authority in the field per se. So I think it's a really exciting thing to be part of, like what Vaughn mentioned earlier about the Qiskit Advocates program, or open source contributions, and even QGrade making like access to all of these platforms available is definitely something that will really allow many people to enter this field. So yeah, thank you.
yeah, I guess if you don't mind me just adding a little bit more.
Yeah,
I
absolutely.
did plug CDL a good amount, so I'm going to plug the accelerator that QGrade is part of, and it's called Duality Accelerator. We just had like a talk about each of the startups this morning, and I think if you're much more further down your career, than myself, and you have an idea in quantum computing and you have been heavily involved, you know, there's like an even more augmented version of what I mentioned, where, you know, you work with industry to build your own startup, and you essentially go through and, you know, realize maybe like the coolest part is of your dream, which is just to like make something that's your own, that's a company. And that's where you essentially work very closely with, you know, a lot of companies like Amazon, as well as get intros to other companies like BMW as well. And I think though that's also another maybe like career step further down the road, once you're like very well established and can at least give yourself like a 60% confidence about the certain problem you're trying to solve might be worth solving and be convincing for users and investors in the short and long term. So yeah, I think that might be also a really cool opportunity if anyone's interested in applying to like an accelerator as well.
Yeah, so everyone, please check out Duality Accelerator. And yeah, I was also wondering, how exactly do people, like if you have a really good idea and even if you're, you know, 60% certain that it's going to work out, what are some other specific action items that you can go to like make your application more competitive for the accelerator? How do you go about making your startup poised for the highest chances of success?
I can talk a little bit, and I think I'd love to hear Jake's perspective and maybe, you know, other people's as well. I think that's where you definitely require, in somewhere as deep tech as quantum, like you do need like a PhD for that. Like you definitely have to have that understanding, the credibility, a lot of ability to essentially understand the field that you're trying to essentially build a company in. It's very simply that, like you do need to be well versed in the research, because right now we're still very much, you know, at this point where the research is much more important than anything else. And so yeah, I think that's something where you would have to get like a PhD, and you would have to kind of have spent a lot of time within both industry plus research, I think, and are maybe very comfortable with like learning very new skills. Like, goodness, you might have to become a front-end engineer for like half a month or maybe even more. So stuff like that, just, yeah.
And Jake, would you like to add anything to that?
Yeah, no, and I think it's a good point. I also just want to identify another pattern I've seen, which is around, I would say there's about, you know, 3 macroscopic factors that I think are really important, at least that we see in terms of success factors for startups in quantum. That's around kind of the team, the product, and the kind of market traction. So for the team, you might have, as Ricky said, somebody on the team who's kind of a quantum expert, PhD level, postdoc level, really focused on that side. You might have somebody who's maybe a more traditional software engineer, maybe on the machine learning side, knows a little bit more about cloud and high performance computing. And then maybe someone else who's a bit more of a business domain expert, who knows a bit more about the selling and actually taking, you know, maybe certain expertise of the space and knowing the problem space quite well. The product side goes from everything from the defensibility of the product. So you might have an IP strategy around patents, or more of a trade secret / execution strategy, everything to, you know, how much of an improvement is the product bringing? Is it a 10, you know, maybe 100 times improvement to what you're doing? Then this is obviously going to be much better. You know, how much of, you know, how easy is the product to use for the customer, these pieces. In terms of market traction, so this is where it kind of really was a bit of a shock to me, because the way I always understood it in the world of, you know, science and technology was, if they can demonstrate that that's in the lab or demonstrate some form of this, like, wow, that's already moving the needle so much. But really, what moves the needle almost 100 times more in the business world, investment world especially, is actually showing that customers are willing to pay for this, and actually finding, using it as a way to identify that, hey, this is a big enough problem for them that we can make a sustainable business for this. So those 3 pillars, I think, are almost essential to build the foundation from, an early stage company that actually evolves into something that's, much more scalable.
Thanks, Rick and Jake, for these valuable suggestions. And before I hand it off to Shay, I'd like to ask a final question to everyone on the panel. And I think that's a question that a lot of people will be wondering, and it's this tension between needing to meet your long-term goals of your organization and the, I guess, more short-term deliverables and pressures that you face, like whether that be in academia where you want to pump out as many papers as you can in a short amount of time, or to get research results, or in an organization where you have to meet a certain financial target. So I was wondering, how do you exactly find balance between investing in your long-term goals and meeting your short-term requirements? If anyone has anything to say about that.
You can comment on this. If anyone else, I'd love to hear everyone else that have some points as well. We actually just went through this exercise with our team, and we were kind of determining what were the short-term versus long-term kind of objectives to focus on. So there's actually a framework called OKRs, Objectives and Key Results. And basically it's a goal-setting method where, what we did was our team would kind of come up with what these objectives were and then build kind of key metrics around them, about 3 each. And then as we had a meeting, we kind of debated and discussed where those metrics could be for the next quarter. So this was kind of a June, let's say. And then also kind of this more long-term version, which is kind of the more yearly piece. And what we did is once we kind of agreed on where there's overlap and differences, we kind of came back with a second iteration where then we were a bit closer to those objectives and key results. And then by the end, we kind of agreed on what those 3 things would be. And in our case, there were different initiatives. So we had one around the boot camp, which is something we're doing each year, this kind of 4 to 5 week program, something around our recruitment and sales, which is kind of to bring more ventures and individuals into the program. And it's something around kind of the partnerships and opportunities that we are nurturing and currently pursuing. So again, it kind of broadened everyone's opinion, but also kind of anchored us to, okay, here are the things that we're going to do in the short term, things that are achievable, specific, and measurable, but also kind of thinking about how those play into our long-term objectives.
I think it's very funny that you say that the main goal in academia is pushing for papers. I mean, it's kind of true that we want to publish the knowledge to everyone else, and it's kind of a way that you communicate your result, what you're doing, your group to the world. I think academia is comparing to industry, I think there are lots of things that I find that is not the same with the industry. For example, your team is less diverse, for example. Like some of the group only have people coming from physics, or some of the group only have people coming from mathematics. And then in academy, but then in academy, you have a lot of, also you don't have the same amount of budget, I guess, comparing to the company. You have a limited resource of funding. But I think the goal are a bit different in the sense that we test the system in a much more preliminary stage. I don't know, for example, in an ion trap system or in a neutral atom system, we kind of test different kind of, for example, possible interaction, possible entanglement scheme, possible way to generate like long coherence qubit with like fast interaction time, and this kind of stuff, I guess, are preliminary step to get on the bigger scale in the applied industry, I guess. So I think the target is a bit different in the academic environment and the industry environment. But but definitely I think that in industry you will have a better work-life balance, I guess. But in the academy, for example, if you have your own idea, your own project, you can build your own group, and you have much more autonomy, probably, I think, compared to a big company. But also you're testing in a much more fundamental preliminaries, and that like less apply stage. That's what I think. So I think the goal are slightly different for us. For example, in our lab, the short-term goal is to get entanglement. The long-term goal is to like investigate different like revert interaction scheme. So yeah, it's definitely not the same goal with industry, where you have a defined application goal that you target, I guess.
Yeah, thanks so
But
much.
yeah, definitely publishing paper is the goal. I agree on that.
Yeah, yeah. I think it's very interesting how you sort of describe this bigger picture of where academia fits in with respect to industry, because a lot of the times I feel like people might think of them as completely disjoint fields. And yeah, I think it's important to emphasize that how important like foundational research is. And yeah, thank you so much. And yeah, lastly, Shay, I leave the floor open to you if you'd like to share a few words or tell us a little bit about how you got into QC.
All right. So I probably have the most non-traditional path into quantum compared to you all. I actually am the talent pipeline development lead over here in quantum. So my day-to-day responsibilities are centered around recruiting and pipeline development. So listening to you guys all talk, a lot of what I do is around that, right? So we are working at IBM, we're broken into pillars, right? So we have our research side and we have our technical side. So, you know, our technical side, we have our hardware, software engineers that we recruit for. We have our Qiskit developers, designers, product managers, offering managers. So basically, a lot of what I do is I work at different events, you know, as far as like conferences, like our major conferences, you know, scouting for, you know, talent to bring over into quantum, as well as university recruiting as well. So a lot of what I do is, you know, I collaborate with you know, our community education community team, where we work to develop and innovate and operationalize our recruitment and student engagement platforms, because a lot of my focus is around intern hiring and early professional hiring. And so basically I manage those strategic partnerships and collaborations internally as well as externally that is related to recruiting and our pipeline development. I also work to pilot, you know, different, you know, potential programs and new initiatives related to recruiting and pipeline development. So a lot of what, you know, we do is, as you guys mentioned, like the Qiskit advocates, you know, we encourage students, you know, when we meet them at different events, you know, career fairs, to get involved in Qiskit, right? We have a Qiskit textbook course that we also, you know, encourage students to take, because as you guys know, that stands out on resumes, right? So, you know, you see, oh, a Qiskit advocate, or okay, I've taken a, you know, a quantum course, you know, introduction into quantum. Those are things that, you know, we look for. We also introduced in the program here at IBM, you know, we become quantum certified. So that's also, you know, a plus, right? So as it relates to, as you guys have been talking, like the academia side as well as the technical side, you know, we get students, we get inquiries from both, you know, areas. And so, you know, we have a LinkedIn page where, you know, we promote a lot of what we're doing here, what we're looking for. We host a lot of different type of, you know, like workshops, roundtables where we give our students an opportunity, a chance to meet with our, different leaders within the quantum organization to kind of help them, mentor them to how you can get into quantum, what things that we're looking for as it relates into the fields that we hire for, as far as like different positions or roles that we have here. So we just closed out our internship season, where we probably had about over, I would say 5,000 applicants that were really interested in coming to work for us, which is great, right? Because it shows that the field of quantum is growing and it's going to continue to grow, and that a lot of people are interested in working in the field of quantum. And so that's a lot of what our focus is just being like the major or central hub for the quantum industry, where we not only staff within, right, but we help the industry staff externally as well. So over the last 4 or 5 years, we've seen a lot of growth, and we're hoping to continue to see that growth as we continue to push and just make a name for ourselves in the industry, and also, working with students to let them know that, hey, I don't have a physics background, but that does not mean that you still can't have a path in quantum, right? Well, my major may be computer science, so how does that relate to research? So kind of helping them to understand how it can all tie together and how it can all work together, but they can still take a path in quantum. So that's kind of a lot of what I do day to day. And it's been very rewarding for me, because coming from a non-technical background, having the opportunity to work with, our leaders in quantum from both the academia side and the technical side, right? It gives me an opportunity to learn more about the field of quantum, so that when I do, recruit at different events, that I sound somewhat intelligent about, the field of quantum. So that's what I do.
Yeah, thank you so much for sharing. I was wondering if you could share a little bit more about how did you find out about this opportunity in quantum, and like what was the sort of path that led you to this point?
So I've been with IBM, June will be 22 years. And so I joined the company as a college hire, and I had more of a IT background. And so throughout my 22-year career, I've held numerous positions. I've worked in, like I mentioned, IT, I worked in supply chain, I worked in finance. So I just held numerous, positions here. However, one of the things that, early on, as I was being mentored, as I seek to have mentorship from, a lot of the executives within the company, is one of the valuable things that I learned along the way is to always place yourself in the strategic, part of the business, or where there are core skills. And so I knew that quantum was new in IBM, and I knew that it was a strategic area. And I knew that it was an area that I could continue to grow my skills in. And so one of the things that I've always tried to pride myself in is ensuring that I make myself marketable. And making myself marketable is always, ensuring that my skills are, just where they should be, within IBM and within the industry. And so just reading about quantum and just kind of understanding a little bit about what the organization was doing and where it was going, I saw this position, become available, and I just asked, reached out to the hiring manager and said, hey, this is a position that I'm interested in. I would love an opportunity to have, to be able to talk to you. And, just because I've had, a background in different things that he was looking for, it gave me an opportunity to come over and work in this organization. So.
Yeah, thank you so much. That's really interesting to hear. And as like what you mentioned about marketability, I think is often forgotten about point, because I think people, especially students, they are very focused on, I guess, learning and improving themselves. But if they don't demonstrate that to the world, then that's half of the potential that's lost, I guess. Like, you want to fully capitalize on that, and I think that's a really important lesson. So thank you for sharing. And like, also related to that point, I think IBM, like for example, when you give out the badges for Qiskit Advocate or the Qiskit Developer Certificate, I think these are good things to pursue as a student, because you can then like gain step-by-step concrete skills to display on your resume, for example. And I'd also like to invite Maria, if you'd like to speak a little bit about the Microsoft Student Ambassadors Program that I know is still not real out in the public yet, but if you have a few words to share about what are in the works for that and what your vision for that is after this, that would be amazing. So I have a, yes, go ahead, Maria.
So it is in very early stages. So one program that we have right now for recognizing massive contributions to our community is Microsoft MVP program, Most Valuable Professional program. It is less student targeted and more professional targeted. And we have a quantum part in it. I'll finish talking and I will share a couple of links if I can pull them up. The student program, Microsoft Learn Student Ambassador Program, targets basically people who are excited about various aspects of technologies and on one hand want to get involved with Microsoft's work on them, and on the other hand to share their excitement with their peers at various universities. So we are just starting to look at getting a piece in this program because it's Microsoft overall program. There is a section called Emerging Technologies that we will be part of. Basically, stay tuned with our Twitter and blog, and once we have the details, we will share them.
Yeah, amazing. Thank you so much, Maria. And I guess I'd like to end this discussion by directing this question at Shay. So I think you're in a really unique and special position to create a diverse and equitable quantum workforce. Since it's such a young and budding industry, it's really important to put in as much work into these areas as possible since the very inception of the field. So I was wondering, first of all, what are some of the unique challenges that you face in this effort that you don't see in other fields, such as in more developed like industries such as IT? And secondly, what do you think moving forward should be, what do you think companies and universities should do to actually create a more diverse and equitable workforce?
That's a very good question. That's a very good point, because that's a lot of what I, do is help to build a diverse and equitable workforce. And one of the key challenges is that, partnering with our underrepresented, minority institutions, right, which we call our minority serving institutions, or our R2 institutions, where quantum is not offered, right, or universities where the curriculum are not as rigorous as, schools like the Yales and the MTIs, things like MITs and things like that. So we work with faculty to work with their curriculum to say, hey, why don't we introduce quantum into the curriculum. In addition to, I think a lot of times students hear the word quantum computing and they get intimidated, right? They feel like, oh, that's too hard. I wouldn't qualify to be working in a field like quantum, when in all actuality, they could, right? Because keep in mind, it's not just all research-based, meaning it's not all physics-based. It's, computer science, engineering. And so a lot of it is just educating our students to help them to know that they could qualify. They may not have the skills that we're looking for today. However, we have a nurturing, pipeline program where, as I mentioned, we might have resume, workshops. We might have networking and advocacy roundtables, where we just kind of mentor these students to help prepare and guide them. And that is through our education program, through our Kiskit textbook, becoming Kiskit advocates, working with mentors to kind of help them and kind of guide them into like the next steps they should take and how to upscale their paths into a field like quantum. And so I think that with us now, really partnering, strategically now with more institutions and recruiting at more events, I think that more students are becoming more, interested in inquiring more. And because of that, they're reaching out more, wanting to know what steps can they take. And so we're helping them to prepare them for that path. But I think it starts a lot of times within the institutions, working with the faculty to help them through their education program to start incorporating courses like quantum into their, part of what their studies are. And then that's helping shape their future to say, hey, quantum wasn't here 5 years ago, but quantum is now incorporated into part of their, into the institutions, into their curriculum.
Yeah, thank you so much for those words of advice. And yeah, I definitely think from a student's perspective, quantum has definitely been, I can see the amount of effort put into it to make it more accessible to students. And like whether that's from IBM's front or Microsoft's front with the Katas or even with Ricky's Kubrick platform, I think there's a lot to be learned here about making this area and demystifying this area. Yeah, so before I hand it off to Wyatt, I'd like to ask if anyone else has anything to add about anything. And if not, I'll hand it off to Wyatt.
Yeah, I was going to end our session by saying it would be great if you all could turn on your video and we could get a quick picture and just to remember who all we had here today, and that'd be lovely. Thank you.
I think Maria might be on one screen only, so
Yes.
we can go ahead.
Okay. Picture time. Okay, got it. Awesome. Thank you for joining us too, everyone. That was really insightful, and I'm so grateful for all of our mentors here. And we have more events later tonight. Please look at our schedule on our website. We have a social mixer starting in 30 minutes, and also a Fermilab virtual tour and QBraid, introduction to QBraid lab later tonight. So please join us, and thank you so much.
Thank you all. See you.